In this lesson, we'll learn about something called the correlation coefficient. And what the correlation coefficient measures is how strong the relationship is between our variables. I mean, we can graph a line of best fit through a scatter plot, but how do we really know if that line is a good predictor or not? Well, the correlation coefficient tells us. So here's some information about the correlation coefficient. Take a moment, copy down some of this information. So the main thing is when we use the graphing calculator to find this, we call it the R value. So we're going to look for that variable R, and you'll see where that comes up in a little bit. But the main idea is that the closer that this R value is to either -1 or to +1, the stronger the relationship is between the variables, and as a result, the more predictable a result will be if we use our line of best fit. So that's the key right there. So here's a few examples of scatter plots and their corresponding R values, their corresponding correlation coefficients. It's probably a good idea to pause the video as well and copy down some of these pictures here. So a few things about these here. What you're going to notice is this first one here, the positive correlation one there. If you notice, when the R value is +1, the positive tells us that it's a direct relationship. As X increases, Y increases. The slope of the line of best fit would be a +1. And in fact, it's a linear relationship. When R equals 1, it is linear. The dots form a perfect line. And the same with the perfect negative correlation, when the R value is -1. It doesn't mean that the slope is -1, but what it means is that there's an indirect relationship here. As X increases, Y decreases, and it does so following another linear relationship. You can draw a line that goes through all the points. Now, as that R value goes to about 0.9 or -0.9, please notice that the correlation is still pretty high. It's still either high positive or high negative. And if you look at the corresponding scatter plot, it's not linear. It's not a perfect straight line, if you will, but it's pretty darn close to it. A line of best fit would probably go through many of the points, and the ones that it didn't go through wouldn't be too far off. If you take a look at the one that's about 0.5 or -0.5, that's what we would call a low positive correlation. Anything below about 0.7 is not really considered a very strong one. It's considered a kind of average or weak. So this low positive one, or the low negative correlation, that's when the values are a little bit more scattered. They're a little bit more spread out. And then when you finally go to an R value of 0, an R value of 0 is when no correlation can be made between the two values. It really doesn't make sense to relate them. And that means that it's completely scattered, it's random. There's no way that any line would be able to predict that data. So what I want to do is I want to show you a little bit of a slider here for a minute. This is a website, if you wanted to go to it. It's a psychology website. But what's really neat about it is how it shows how the correlation will change based on what we want, what our points will look like. So what I'm going to do is I'm going to grab this slider, because right now the correlation is at 0. So as you can see, it's pretty random. And even this dotted line doesn't really make sense to go through that, because it doesn't really predict any of our values well. But let's start increasing this. Let's maybe bring it up to about 0.75. So we're getting to be one that's about a pretty solid relationship. As you can see, the dots are a lot closer to the line. It's more linear. It's still a little bit scattered, but now our line better models our data. As we get higher, if we get into like 0.93, we're almost forming that straight line with our dots. And if we go all the way up to 1, the dots are linear. And going in the other direction as well, if we go to, say, -0.5, you can see now that the trend is a negative trend, that the data kind of goes down from left to right. And again, as we get closer to -1, the relationship becomes a stronger relationship. And when we do equal -1, the dots are exactly linear as well. So hopefully that slider helps give you a nice visual of how that correlation coefficient changes based on the data. So last lesson, we talked about relating calories in a hot dog to the milligrams of sodium that it contained. So you might remember that data that we got there. But what we want to do here is we want to figure out what the R value is. On the calculator, we would type in our data. We'll do the menu 413. I'll give you an opportunity to do that in a minute, just like we did before. Last time we got the M and the B. Now we're looking at the R value. So this R value, this correlation coefficient, if we round it to the nearest hundredth, R is approximately 0.94. So use what you've learned so far. What does this value say about the strength of the relationship between the amount of sodium in a hot dog and the number of calories in it? 0.94, that's pretty close to 1. So I would say that this is a strong relationship. And also because it's a positive value, it's a strong positive relationship. Positive meaning that as the number of calories increase, the milligrams of sodium increase as well. Strong because it's very close to positive 1 and it's quite far from 0. So earlier I said it was going to be your turn to practice a little bit. Here's your opportunity. Mr. Kunz came up to me a couple days ago. You know those social studies guys, they can't do math. And he says, hey, I wonder, is there a relationship between the number of homework assignments that my students miss and their corresponding test scores? Here's the data that I got. So he gave me about 10 or 11 pieces of data. So what I'd like you to do is follow the steps that you see on the screen here as if you're getting the equation of the line of fit and locate your R value. Well, let's see how you did. Does your screen look like this? So did you get your R value to be about negative 0.2632? So if we go to the nearest hundredth, negative 0.26. Let's think about what that tells us about the relationship between the data. So first of all, it's pretty close to 0. So that's not going to be a strong relationship. That's going to be a weak relationship. And because our R value is negative, it's a weak negative relationship. And we should kind of expect that. The more homework assignments you miss, the lower your grade will be. Now, is it a rule? Does that occur all the time? No, it doesn't. But it might be a pretty good predictor of what might happen. So at the end of this lesson, you should be able to use your calculator to determine the R value, the correlation coefficient, and then use it to tell whether it's a strong relationship or a weak relationship. And even identify the R value or an approximate R value from a scatter plot, knowing that if it's a strong relationship, the stronger it gets, the more linear the data will become.